We're back and we're continuing to look at the stationary point and points on their nature, right? And by the way, I should have points, right? More than one points and their nature. Now, we had looked at the stationary point for this function y equals x squared minus 2x minus 3, and to find the location of that stationary point we differentiated. In previous videos we differentiated this to find dy by dx, which is the gradient function, equated it to 0, and then found the value of x. When we had 2x minus 2 equals 0, we found that x was 1. When we substituted 1 for x in this, we found that y was negative 4. So the minimum, the stationary point was at 1, negative 4. To find out whether it's a minimum or maximum point, what we did in one case was to find a value to the left and to the right, and they were higher, the y value at, what was it we used, 0.9 and 1.1, and they were higher than at 1. So it means from the left was high, we had to go down to the stationary point and then go back up to the point, the y value on the right. So we had to go down and then up, meaning we had a minimum point. Then we use differentiation as a next method of finding the nature of the stationary point here. We chose a point to the left of 1 and to the right of 1. Of course, when we put 1 in the gradient function, what we got is 0, because the gradient at the stationary point is 0. Then we put 0.9, the value to the left of 1, and we got 2 by 0.9 minus 2 gave us negative 0.2. So the fact that we had a negative on the left, a negative gradient on the left, means that what we have here is we had a negative value to the left. All right. So what we had at the stationary point, the gradient was 0. I want to get my line to touch the curve. All right, let's say that line is touching. Doesn't seem to be touching. Just a bit closer. And the thing is, I don't want it to cut through the curve. All right, let's say that is touching the curve. So at 1, dy by dx is 0. Right? When we substitute 1 here, we get 0. When we substitute 0.9 for x, we got a negative 0.2. But the important thing is that it's negative. So we got a negative gradient. So the tangent to the curve on the left would be negative. And then to the right, we got a positive when we put in 1.1 to the right. 1.1 is to the right of 1, the stationary point. When we substitute 1.1 for x, we got 2 by 1.1 minus 2, which is positive 0.2. So the gradient of a tangent to the curve there is positive. So that shows that what we have is a minimum value. All right? We go negative, 0, and then positive. So at the stationary point, or the turning point, we have the gradient turn from negative to positive. All right. So there we have that. Now, what we want to look at is another method of finding the gradients of the curve. Now, this other method consists of doing this. What we do after having found dy by dx, we differentiate again. So we differentiate the derivative. So it's like we're doing dy by dx. squared. But the way you generally write this is this. You say d square y by dx squared. Alright? And this is what you're going to differentiate. Dy by dx. Now dy by dx is 2x minus 2. When you differentiate this, what you get is 2. Now, the fact that d square y by dx is positive means you have a minimum value. What happens is this. If d square y by dx squared is positive, then you have a minimum value. If d square, let me write that again. If d square y by dx is equal to a negative value, then you have a maximum. Alright? Now, let me write that. I'm going to have to erase this. So let me open up another screen and write it down. Alright. If d square y by dx squared is positive, then what you have is a minimum point. If d square y by dx squared, if d square y by dx squared is negative, then you have a maximum point. See that? Now, why is that the case? Now, the thing is this. This is the stationary point. dy by dx is negative here. As you get closer to the stationary point, dy by dx, still negative, but it has increased. It could have been from -5. It could have been from -5, then -4, then it went to -3. Then, of course, at the stationary point is 0. So it went to 0. After you pass the stationary point, it had gone to 1. So it went to 1. Then it went to 2. So the thing is, the gradient constantly increase, right? The first derivative is telling you the gradient at a certain point. The second derivative is telling you the change in the gradient. And remember, we move from left to right. So if the change in the gradient is positive, it means the gradient is increasing. It's becoming more and more positive. If you go from -5 to -4, you are going up. You're getting more positive. Going from -4 to -3, you're getting more positive. You're getting more and more positive. What that means is that the gradient is becoming more positive. So you have a minimum point. You're going down and then up. So the fact that d squared y by dx squared for this is 2 means that you have a minimum point. Alright? That's what happened for this. In this situation, you have a minimum point. Now, we're going to look at what happened when you have a maximum point, but we'll do that in a different video, so I will see you then.